We will review the material for chapter 2.4 to 2.6. In first part of chapter 2, we learn about central tendency, and in the second part of chapter 2, we learned about measures of variation. In first part of chapter 2, we learned about median, mode, and mean as common measures in central tendency. And in this part, we also learn about range, variance, standard deviation, percentile, quartile, interquartile range, and z-score as measures of variation or dispersion. Range is the simplest measure of variation. It is calculated as a difference between the maximum and minimum values in the dataset. Also, variance is calculated as the average of the squared difference between each data point and the population or sample mean, and quantifies the overall dispersion of data points. And standard deviation, just like variance, we can calculate for both population and sample, and is the square root of the variance and provides a measure of dispersion. A normal distribution empirical rule, also known as the 68, 95, 99.7 rule, estimates the proportion of data within 1 to 3 standard deviation of the mean. Approximately 68% of data falls within 1 standard deviation of the mean, and approximately 95% of the data falls within two standard deviations of the mean, and approximately 99.7% of the data falls within 3 standard deviations of the mean. These rules are particularly useful when dealing with normally distributed data because they provide a quick way to estimate the percentage of the data points within certain range of values without needing to calculate specific percentiles or perform complex statistical analysis. Chebyshev's theorem provides a bound on the proportion of data values that lie within a specified number of standard deviations from the mean in any data set, and it is used to make statements about data spread without assuming any particular distribution. And this is a formula that to calculate the percentage of values falling in a specific intervals. For 2 standard deviations where k equals 2, at least 75% of data must fall within 2 standard deviation of the mean, and at least 89% of data must fall within 3 standard deviation of the mean, where k equals 3. And percentiles are statistical measures used to describe the relative position or ranking of a specific data point within a data set. Percentiles divide the data into 100 equal parts and provide values that represent a specific percentiles. Quartiles are a set of 3 values that divide a data set into 4 equal parts, each containing approximately 25% of the data. Quartiles are valuable in statistics for understanding the spread and distribution of data. The 3 quartiles include first quartile or Q1, contain 25th percentile of the data, and second quartile or Q2 represent the 50th percentile of the data or median of the entire data set, dividing the data set into 2 equal halves. And third quartile or Q3 contains 75th percentile of the data. Interquartile range quantifies the spread of data within the middle 50% of the data set. It is calculated as the difference between the third quartile Q3 and the first quartile Q1. In other words, the IQR represent the range of values that encompass the central half of the data. Box and whisker plot, commonly known as a box plot, usually visually represent the five-number summary and help identify outliers and the spread of the data. In order to create a box plot, we first sort the data in ascending or descending order and calculate quartiles starting with Q1, the first quartile or 25th percentile, and Q3, the third quartile or 75th percentile, and we calculate the median Q2, the 50th percentile, and then we compute the interquartile range as Q3 minus Q1 to determine lower or upper whisker limits. And we identify outliers and then we create the box plot. Z-score Z-scores, also known as standard scores, are statistical measure that quantifies how far a data point is from the mean of a data set in terms of standard deviation. We also have positive z-score. A positive z-score indicates that the data point is above the mean of the data set. The larger the positive z-score, the further the data point is from the mean in the positive direction. And we also have negative z-score that indicates the data point is below the mean of the data set. The larger the negative z-score, the further data point is from the mean in the negative direction. Also, a z-score of 0 means that the data point is exactly at the mean of a data set. Thank you so much. We will see you in the next video.